I guess the next talk is on reproducibility and replicability from Jeff, or Joseph. Sorry.
Thank you. It's an honor to be here to present this talk on decentralized infrastructure for reproducible and replicable geographical science. I'm Dr. Joseph Holler from Middlebury College. My colleague, Dr. Peter Kedron, is probably listening in from University of California, Santa Barbara right now. He sends his greetings to all of you and regrets not being here as he adjusts to the hardships of his new home landscape there. I'd like to start by acknowledging the support of the National Science Foundation, and in particular to the support through the Geospatial Fellowship for COVID-19 researchers, which was sort of administered by Dr. Xiaowen Wang and supported immensely by Anand and Becky, if they're in the room right here. It was a great learning opportunity to see how other researchers try to use this infrastructure to do their own work more reproducibly. So I'd like to start by talking about a vision for veridictical spatial data science, sort of published by Peter Kedron and Sarah Bardeen in 2020 in a conference paper based on Yu and Cumbier's article in 2020. So what is veridictical spatial data science? It is a principled inquiry to extract reliable and reproducible information from spatial temporal data with an enriched technical language to communicate and evaluate empirical evidence in the context of human decisions, domain knowledge, and geographical confounds, supported by a system of external validation and evidence accumulation based on the purposeful replication of findings across space and time. So it's about improved scientific communication to inform the public in sustainability decision-making, and it's about improved communication to other researchers so that research can be internally validated through reproduction studies and externally validated and generalized through replication studies. So our current research project in developing R&R in the geographical sciences has three main activities. First, we've been surveying the state of the field by creating a database of researchers publishing in geographical journals, asking questions about reproducibility and replicability, and reporting essentially the state of practices and knowledge in the field. The first of those papers is about to come out in the Annals of the AAG, and you can find a preprint of it by following hexrr.github.io. That's got links to all of our research down below. Secondly, we've been conducting reproduction and replication studies with our graduate and undergraduate students. And thirdly, we've been developing pedagogy and evaluation system for that pedagogy to teach students at both undergrad and grad levels reproducible research practices for geography and to experiment with teaching methods through doing reproduction and replication studies. This talk, I'm going to focus on ancillary activities to doing the reproduction studies and teaching reproducibility, which was, we've been iteratively developing a template for a reproducible research compendium, and pairing with that, we're writing a manual for conducting an open science research process while using that research compendium. This talk will emphasize the context of selective inference and existing infrastructure for open science research practices in the geographical sciences, and emphasize three novel challenges to geographical research for sustainability convergence research. And those are placing the geography and spatial extent of projects, understanding diverse and complex data sources, working with restricted data sources, working with very complicated computational environments, as we saw in the previous talk, and coping with the expanded degrees of freedom for researchers doing convergence research in geography. So that we're all on the same page, what does it mean to use R&R for self-correction in science? We like this confusion matrix by Christensen et al. We're in the top left corner, top left quadrant. You use the same data and the same procedures to internally validate a study through a reproduction study, which leads leads naturally to the top right corner, where you start adjusting researcher decisions to test for uncertainty and stability in that original research through a reanalysis by adjusting the parameters of the study. And if you're interested in externally validating or generalizing a study, you sort of try to repeat the same procedures in a new, with new data or in a new geographical context, moving to the bottom left quadrant for a replication study. So convergent spatial data science. If we think about the challenges here, an increasingly industrialized spatial data science, we have increasing computational complexity and intensity enabled by big data and by open science packages for spatial data science. And we have expanded researcher degrees of freedom. If we think about the spatial data science research process, at each point in the data science lifecycle, we have increasing options in terms of decisions in the research design, which multiply and compound into exponential number of increasing permutations for possible outcomes from that research, as you kind of see on the illustration at the right. This leads to a risk of selected inference, where if a researcher then chooses one single path through all of those permutations of decisions and only reports that one single path of permutations to the public, then it compromises the inferential power of the study and makes it unlikely to be replicated. And one example of this is 5 permutations of the same study that we were replicating, changing very minor decisions, and that research design actually changed and moved some of the parameter estimates outside of the original margins of error for that study. So for a similar audience in the Spatial Data Science Symposium in September, we asked the group about 11 different open science research practices. And we observed that the work that iGuide is currently doing is heavy lifting, in that iGuide is working a lot on the reproducible computational environment, which is third from the right, as the third least well-known or well-adopted practice amongst geographic researchers. And this talk, I'm emphasizing actually the research compendium and the pre-registration, which are the least adopted practices in our discipline. So what infrastructure already exists to support open science research practices in our research community? We already have support for reproducible workflows in the form of computational notebooks using Jupyter and GeoPandas, or R Markdown using SF and STARS, for example. The researchers at Harvard have been extending the NIME graphic workflow platform to do geospatial analysis. And we have shared computational environments like CyberGIS-X, a predecessor of iGuide, which we've all been hearing about for the last few days, and related HydroShare. Other examples are O2R or Binder. And we have data sharing platforms and archiving platforms for our computational outputs, or our research outputs, like Figshare, Zenodo, and OSF. And finally, Doug Richardson and Mei-Po Kwan have been working on a geospatial virtual data enclave with the idea of having a platform for sharing restricted data for credentialed researchers. And finally, at a national level, this is the year of open science, and so all of the federal agencies are moving towards more open data requirements and more open science requirements for federally funded research. On a decentralized level, projects like Works or Project Tier have been developing templates for a research compendium, templates for analysis plans for pre-registering your studies, and workflows associated with those templates. These sometimes include executable code and computational notebooks. Some of the compendiums are designed to be on Git for version control, and they have some modicum of advice for documenting metadata. The components might look something like the blue box on the right, which is actually our data structure for organizing data within a research project. However, none of these efforts in our survey of them have addressed the novel challenges of geographical research and convergence research, which I've already mentioned. So let's talk about how we have started to address those. First of all, we need to be able to place our projects with metadata and essentially make a geographic research project findable. Where does it exist in the Earth? And so at the project level, we can use the Dublin Core standards for metadata. And we suggest enhancing the coverage field of the Dublin Core metadata standards so that we explicitly define the spatial coverage in terms of spatial extent and spatial resolution, explicitly define the spatial reference system for the study, and similarly the temporal coverage and temporal resolution. I was astonished when a colleague of mine was trying to do a spatially explicit literature review of remote sensing studies of deforestation in the Congo Basin and could not place all of those studies on the map because they were lacking sufficient metadata at the project level. We are also in Convergence research trying to integrate diverse and complex data sources and manipulate those data sources into a common analytical frame to answer a question. And so geographers have already developed the tools for exchanging and documenting metadata about our geographical data sources. It's now up to researchers to more thoroughly implement those standards, for example, from the ISO 191 suite of geospatial standards. In our template, we have decided to use the Markdown language to write these metadata standards, kind of implementing the 191 suite of standards, because it's easy for a human to write it and read it, and it's also easy for a computer to read that. And it's easy to render and view those as Markdown documents on GitHub. And you can also sort of write script to import them into your analysis plans when you're writing in Jupyter Notebooks or R Markdown. We're additionally challenged by managing restricted data, and our data may be restricted by its sheer volume and size. It may be restricted by proprietary licenses or confidentiality agreements. And so we need to intentionally design our localized, decentralized research infrastructure to accommodate that confidential data. So we have private folders in our research compendium that are ignored by Git, so they aren't synced to GitHub or GitLabs or whatever platform you use. And the idea is that if you get credentialed access to a restricted data source like the DHS surveys, you could write the script for that API call in your computational notebook, download the data into the private folder where it won't be transferred to other users, and manipulate that data to the point at which it could be shared with the public. So the workflow on the right is sort of gray boxed at the top because all of that code would be included with your study, but the data wouldn't be included until you reach the point at the right-hand side where it's already aggregated to an extent that it can be shared with the public. So there's complete transparency about where you're getting the data and what you're doing with it, and then the public, even if they don't have access to the DHS program's data, would be able to execute the code from the point of the map on the right forward to the end of the study. Finally, I need to wrap up pretty quickly here. Alex already talked in plenty in the previous talk about complex computational environments, but in our computational notebooks, we were adding code for both R and Python to intentionally track and record information about the computational environment to make it easier to create containers out of the study or reproduce the computational environment down the pipeline. And finally, the issue of researcher degrees of freedom. So the idea behind pre-registration and limiting the researcher degrees of freedom or the chance of selection bias is that you outline a plan for your research design and you commit that to a repository before you touch the data, before you generate the data or observe the data. If you have to change that plan, it's okay, but you're adding a commitment to transparency to that original research plan and tracking any changes in that research plan. And the thing that I want to emphasize here is that other disciplines have started doing this, and geographers are lagging far behind. And when you look at the templates for doing these analysis plans and registering them, they aren't asking us the questions that are really important in terms of degrees of freedom in geographic studies. So they're not questioning sources of uncertainty rooted in geography, like the modifiable areal unit problem. And they're not sort of emphasizing, declaring critical variables like the spatial extent of a study, the spatial support of the study, and so on and so forth. And so we created our own template analysis plans in Markdown, R Markdown, and Python notebooks so that you can actually write your plan in plain text, submit it to a repository, then fill in the code blocks to make it work, execute that plan, and render a final report, and then submit that to a public repository, and then take your time editing it into a publishable manuscript, but having preserved the full transparency of your project and provenance of your project from the beginning. And so here's an example of one of ours. If you're interested in, how much better are the things that Dr. Holler is talking about right now than simply putting a repository on GitHub with your data and code in it, you could compare a friend of ours, Seth Spielman's paper from 2020, evaluating social vulnerability indicators, criteria, and their application to social vulnerability index. That paper is on GitHub with the data and code. It took a research assistant 8 weeks this summer to massage that code into a form that will work with current packages and sort of figure out which code was actually running the study and all of the dead ends of code that were still in the repository, and which data sources were actually still important to the study after all of the things that they had added to the repository. I will give them credit. They have one of the most reproducible studies I've seen from geographers at an outset. But even then, it still needs a lot of work to make it easily communicatable and transferable to other researchers and for other researchers to execute. And so with that, I'd like to thank you for your attention and encourage you, if you're interested, you can find, we've already done 8 of these studies. They're on hexrr.github.io. I'm currently running an undergraduate class in OpenGI Science that uses these studies thoroughly in the curriculum, and that's at opengisi.github.io. So thank you very much.